Hello, welcome to the Day 9 Notes 6.5 Solving Polynomial Equations. So this is our second day of doing section 6.5, and today we're actually going to be solving polynomial equations by factoring. So we're going to take what we did last time, but we have to make sure that we set the equation equal to 0, then you factor it, and then finally you use the zero product property and or the quadratic formula to solve for each factor. Now one thing I do want to mention is that the degree of the polynomial, whatever that degree is, that equals the number of zeros that a polynomial will have. So if you have a polynomial to the second power, it's going to have 2 zeros. A polynomial to the third power is going to have 3 zeros, and so on. Some of those zeros will be repeats, and some of those zeros will be imaginary numbers. So let's go ahead and start number 1. Here we have x squared plus 4x minus 45 equals 0. This means we are going to have 2 zeros that we're finding. And first thing you want to do is make sure it's equal to 0, and it is. Secondly, look for a greatest common factor. There isn't one here, so now we look how many terms we have. We have 3 terms, so we're going to do the little table where we're going to be doing products of a times c. So a here is 1, c is negative 45, so we're looking for 2 numbers that multiply to be negative 45 and have a sum of the middle number b, which in this case is 4. Alright, so we're looking for factors of negative 45. Let's start listing them. 1 and 45. And now because they multiply to be a negative number but add up to be a positive number, the smaller of the two would have to be the negative so that it adds up to a positive. This doesn't work. 2 doesn't go in there. 3 and 15. And again, the smaller of the two would be negative. That does not add up to 4. 4 doesn't go in there. 5 goes in there 9 times. The 5 would have to be negative, and this does add up to 4. Alright, so hopefully you remember from chapter 5 that if the leading coefficient, that a value is 1, you don't have to split the middle term. You could just set up the 2 factors, and they would be x, and then you take this first number, so minus 5, and then x, and then the second number, it's positive 9, so plus 9, and this entire thing equals 0. So now zero product property, you take both factors and set them equal to 0 and solve for x. So here we would get x equals 5, and then x plus 9, if that equals 0, subtract 9 from both sides, you get x equals negative 9. And you could plug those in to check and make sure that they are correct. But again, we started with a degree 2 polynomial. That means we have to have 2 zeros, and we do. Okay, let's take a look at number 2. It's 5x squared equals 15x. So we have to do the first step, which is to set it equal to 0. So that would give us 5x squared minus 15x equals 0. We are ready to factor the first step of factoring, no matter what. The mother of all first steps is to look for a GCF. So hopefully you see that here it's 5 and x, and we'd be left with x minus 3 equals 0. Set each factor equal to 0, so 5x equals 0, and then we get x minus 3 equals 0. From the first little equation, we get x is equal to 0, and from the second one, we get that it equals 3, so those are our 2 zeros for number 2. Let's take a look at number 3. It's y to the third equals negative 64. So first step, set it equal to 0. So I'm going to get y to the third plus 64 equals 0. First step of factoring, look for a GCF. There isn't one here. Then look at how many terms you have. We have 2, so you're looking for a special pattern. Is it a difference of 2 squares? Is it a sum of 2 cubes? Or is it a difference of 2 cubes? And hopefully you do see that it's a sum of 2 cubes. So I'm going to break down the y cubed into y times y times y. And then the 64 I'm going to break up into 4 times 4 times 4. So let's go ahead and factor this. We're going to get y plus 4 because it's a sum of 2 cubes. That's why that first term is a plus, or the sign in the first thing is a plus. Then y squared, multiply the next two, you get 4y. Multiply the last two together, you get 16. This last sign is a plus, and the sign between the y squared and the 4y, you look to the first factor, it's a plus between there, so this one's going to be a minus. And this entire thing equals 0. we use the zero product property and set each factor equal to 0. So y plus 4 is going to equal 0, and y squared minus 4y plus 16 is going to equal 0. From the first one, we get y equals negative 4. Simple enough. The second one is a trinomial, and that can't be factored, and we're not going to factor ever. That's not going to be factorable ever with this pattern. So what you're going to have to do 100% of the time, whether you have a sum of two cubes or a difference of two cubes, 100% of the time you're going to have to use the quadratic formula to solve this. Because even though it can't be factored, every quadratic can be solved using the quadratic formula. So just as a refresher over here, let's talk about what the quadratic formula was. It's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Let's go ahead and do the quadratic formula for this quadratic, y squared minus 4y plus 16. So it's going to be y equals the opposite of b. So if b is negative 4, our value is going to be positive 4, plus or minus the square root of b squared minus 4 times a, which is 1, and times c, which is 16. And we're going to put this all over 2 times a, which is 1. Okay, let's clean this up. We get 4 plus or minus the square root of negative 4, and then that's being squared. That no matter what b is, when you square it, this first number underneath the radical sign should always be a positive, so it's 16. And then we have one minus sign. If you look, there's only one right here. So it's going to be minus 64, and this is all over 2. So this equals 4 plus or minus the square root of negative 48 all over 2. You cannot simplify at this point because that negative 48 is underneath a radical sign. It would have to be, all three values would have to be on the outside. Nothing could be stuck inside the radical. So we have to simplify this negative square root of 48. Well, first, I hope you do remember that a negative underneath a radical sign, an I is going to come out. So we'll actually take that I out at the end. Let's right now just pretend it's a 48 and simplify square root of 48. If you're good at taking out the biggest square factors, that's great. So if you see that there's a 4 that goes in there, hopefully you would see that that's not the biggest square factor. It's actually 16. But if you don't remember, you could always break this down into primes. Let's take out the smallest value that goes into 48. That's not 1, and that would be 2. And 2 times 24 is 48. We're going to circle primes along the way. If you're wondering why I didn't break that down into 6 times 8, I could have, but if I take out the smallest number other than 1 that goes into, or the smallest factor other than 1 that goes into the number, I'm going to have them all lined up, my primes, so I like to do it this way. This is 2 times 6, circle the prime, and then 6 is 2 times 3, circle the primes. Now remember, it takes 2, because this is a square root jail, it takes 2 for 1 to escape, so from those two 2's, only 1 escapes. And from these two 2's, only 1 escapes. The 3 is kind of just left behind. It had no one to help him escape from jail. So what we are going to end up getting is 4 plus or minus. Now, the two numbers that do escape, you don't add them together. You're going to multiply them together. So in this case, 2 plus 2 is the same as 2 times 2, but just know that you do multiply them. So it's 4. And then we have to take care of this negative. And the way we simplify a negative underneath a radical, there's an I. And then square root of what's left over. This 3 was left over, so that's still underneath the radical sign. This is over 2. My silly little way of realizing can you simplify or not is you draw a little heart over these 3 numbers. And if there's a common factor, if there's something that goes into all 3 of those, then you can reduce it. And in this case, it would be a 2 that goes into all 3. So we get 2 plus or minus 2i square roots of 3. Okay? So we started with a third degree polynomial. That means we need to have 3 zeros. Please don't forget about this original one from the beginning, the one that was a one-stepper to get. So we end up with y equals negative 4, and then also 2 plus or minus 2i square roots of 3. Remember, this plus or minus is just an abbreviated way to write two answers. I could write it as 2 plus 2i root 3 and 2 minus 2i root 3, but this is just a shortcut way to write it. All right, number 4 over here, we have 2x to the 4th plus 5x squared equals 3. So we first want to get it equal to 0 because it's equal to 3. So we're going to subtract 3 from both sides, giving us 2x to the 4th plus 5x squared minus 3 equals 0. All right, we're ready to factor. Is there a greatest common factor? No. How many terms do we have? 3. This is where we do our little product sum or the box method, however you want to do it. But in this case, a times c is going to be negative 6. We're looking for two numbers that multiply to be negative 6, add up to positive 5. So again, because the product is negative and the sum is positive, we're going to have one positive number, one negative. Because they have to add up to be a positive, the smaller of the two would be the negative one. And so the first two factors of 6, or negative 6, which are negative 1 and 6, those happen to be the ones that add up to what we need them to add up to, which is 5. All right, now we're ready to split the middle term. So you rewrite the first term, 2x to the 4th. Now, I happen to write my negative one first, my negative value. If you have one that's positive and one that's negative, like we do here, it doesn't matter what order you split those two into. So I could write this as minus x squared plus 6x squared, or I could write it as plus 6x squared minus x squared. But my advice to you is if you have one that's positive and one that's negative, please always write the negative one first, because then when you factor by grouping, you are not going to have to take out a negative, which is usually where kids will make a mistake right here. If there's a minus sign, they'll get confused when you have to factor out a negative. I also want you to realize that you do have to split the middle term in this case because the a value is not equal to 1. If it was just an x to the 4th plus whatever, then whatever those two numbers are, I could just throw them into the parentheses like I did for number 1. But because the number in front of the first term, that a value, is not 1, I have to split the middle term and then factor by grouping. Okay, so the first two terms, they have an x squared that goes into them. And then I have 2x squared minus 1. And then the next two, this is a plus, so I take out a plus, and they have a 3 that goes in, 2x squared minus 1. The values, the polynomials inside the parentheses are identical, so that's a good sign. So now I have x squared plus 3 times 2x squared minus 1 equals 0. Next step, zero product property. You set each of these equal to 0. So x squared plus 3 is going to equal 0. And 2x squared minus 1 is equal to 0. Let's solve each of these little equations. For this one, I get x squared equals negative 3. To undo a squaring, you square root. So you get x equals plus or minus the square root of negative 3. Now you could omit that step if you notice that it is negative, and just write it as x equals plus or minus I times the square root of 3. Okay, so that's 2 zeros. We need 2 more because this was the 4th degree polynomial. So here we'll get 2x squared equals 1. Divide both sides by 2, you get x squared equals 1/2. Take the square root, x is going to equal plus or minus the square root of 1/2. Which if you know how to simplify, great, but we're not going to worry about that right now. Alright, so for number 5 and 6, I'm apologizing. I'm going to change them both when I work through the key. I didn't like these problems. First of all, 5 is not even an equation. It's just a factoring problem. So I'm going to change this to 3x to the 4th minus 75 equals 0. So first step of solving, you make sure it's equal to 0. This one is. Second step is look for a greatest common factor. And there is one here. It's 3. So we're going to factor out a 3. And then we're going to be left with x to the 4th minus 25. Hopefully you remember from the day 8 notes that x to the 4th minus 25, that's a difference of 2 squares. It's not a cube. So this factors into x squared, because x to the 4th, what was that before it was squared? It was x squared. And then 25, what was it before it was squared? It was a 5. So it's x squared minus 5 times x squared plus 5. In the order you write those two, it doesn't matter. You could write the plus sign first and then the minus one in the second one. Makes no difference. Now we're ready for zero product property. This 3 out here, there's nothing you could do to make that equal 0. You're looking for values of x. So if that was a 3x, then that is a term that we would set equal to 0. But because it's a constant, there's no variable there, that has no effect on our zeros. So we're going to let x squared minus 5 equal 0. And then x squared plus 5 equals 0, and we're going to solve each of those. So here we get x squared equals 5. Square root both sides. X is going to equal plus or minus the square root of 5. Square root of 5 is completely simplified. There's no perfect squares that are factors inside of there, so we leave the answer. Here we get x squared equals, and if you subtract 5 from both sides, you get negative 5. So take the square root of both sides, you get x equal to plus or minus the square root of negative 5, and we cannot leave negatives underneath radicals. You have to take that I out, so it's going to be x equals plus or minus I times the square root of 5. And just like before, square root of 5 can't be simplified. There's no perfect square factors, so those are our 4 answers. And this did start off as a 4th degree polynomial, so there should be 4 zeros, and we did find 4 of them. 2 of them are real, 2 of them are imaginary. Okay, so again, I apologize, but I'm going to change number 6. We're going to change this to 2x cubed plus 16 equals 0. First step, check for a greatest first step is to make sure it's equal to 0. It is. Second step, look for a greatest common factor. There is one, it's 2, and we'd be left with x to the third plus 8. And that equals 0. Okay, so our polynomial inside the parentheses is 2 terms. So 2 terms, you're looking for a difference of 2 squares. This is not a sum of 2 cubes or a difference of 2 cubes, and this is a sum of 2 cubes. So I'm going to break up x to the third to x times x times x. I'm going to break up 8 into 2 times 2 times 2. So let's factor this. We have x plus 2 times, circle the first 2 and multiply, we get x squared. Circle the next 2 and multiply, we get 2x. And circle the last 2 and multiply those 2, and it's 4. Always a plus, alternates from the first sign, and this is a minus, and then we have that 2 out in front, equals 0. So we'll get our first 0 from the binomial, but right now I'm just going to do the quadratic formula for the trinomial. And again, it's x equals the opposite of b, so 2 plus or minus the square root of b, which is negative 2 squared, minus 4 times a, which is 1, times c, which is 4, all over 2 times a, so over 2. Let's clean this up. 2 plus or minus the square root of negative 2 squared is 4, minus 16 all over 2. Keep cleaning it up. It's 2 plus or minus the square root of negative 12 over 2. So now we have to simplify that radical. We can't reduce because one of the numbers is in the radical. It'd only be if all the numbers on the outside have something in common. So this is going to be 2 plus or minus. Now 12 is a small enough number that hopefully you could look for the biggest square factor in there. So squares that are smaller than 12 are 9. 9 doesn't go into 12. And 4, and 4 does. So what we could do is rewrite this as the square root of 4 times the square root of 3. Square root of 4 is just a strange way to write what number. You got it, 2, so it's 2, and then I'm going to throw an I after the 2 because it was a negative underneath the radical. Square roots of 3 all over 2. And again, if we could draw that heart around these 3 numbers and they have something in common in all 3 of them, we could reduce it. So we will end up with x equals 1 plus or minus I square roots of 3, and then looking back to this binomial, if I set that equal to 0, I would get x equals negative 2. Okay, for number 7 and 8, I would like you to try those on your own. So first let's try number 7, and then I'll show you the answer, what you'll get for m. Remember, it's m to the 4th, so you should get 4 zeros. And then for number 8, we actually have to put a square here. It's also to the 4th power, so you should get 4 zeros. But let's first look at 7, so pause the video, please. Okay, so here's the answer you should have gotten for 7. M equals plus or minus square root of 10, and plus or minus I squared root of 10. Remember, plus or minus means those are 2 answers. It's just our shorthanded way of writing it. All right, please, again, pause the video and try number 8. Okay, so here are the 4 zeros that you should have gotten for number 8. And if you didn't get the answers correct for 7 or 8, please make sure to see what you did incorrectly in class tomorrow. One last thing I'm going to mention before I go is a lot of times kids get confused. They think, when am I supposed to only factor? When am I supposed to go that step further and set those factors equal to 0 and solve? Well, the answer is simple. If something's not an equation, it can't be solved. So if I said something like x plus 10, go and solve it. Hopefully you look at me and be like, what? I can't solve something that doesn't equal anything. But as soon as I would write equals and then any number on the right side, you can solve it. So if it's not an equation, it can't be solved. Don't magically make it equal 0. If we wanted it to equal 0, we would make it equal 0, thus making an equation that can be solved. All right, thanks for watching. Have a great one.